Pre-statistics. Introduction to Functions, Part 2. Lesson objectives. State the 4 ways to express a function. This is known as the rule of 4. Determine important characteristics of a function. Relation and function review. If you recall from our last video, a relation is a group of ordered pairs. Sometimes ordered pairs can explain the relationship between two variables. In this graph, we have the variable year and we have the percentage claiming no religious affiliation for first-year United States college students. Now we can make this into a relation by looking at, let's say for example, the females. This is the number of years since 1970. So this is a group of ordered pairs, and this corresponds to the data from the previous slide. So we can think of this as a relation, the number of years after 1970, and the percentage of first-year college women claiming no religious affiliation. For example, if we look at the ordered pair 30, 13.2, this would be 30 years after 1970, which would be 2000, and the corresponding Y value is 13.2, which is 13.2% of females who claim no religious affiliation. So this is an ordered pair. Now another way we can express relations is by what's called a mapping. So if you recall, the domain is the list of the X values, the inputs, and in this case this is the number of years since 1970, and then here's the corresponding range, and this is the percentages of females. Now it turns out that this relation is a function because for every input we have one and only one output. If you recall, our first example involved the top US last names. If we were to make a mapping where the names are the inputs and the outputs are the percentages, we would say this is a function. Even though we have two inputs going to the same output, that's still a function. Now what is not a function is if we switch it. If the domain were the percentages and the range the names, we would have an input 0.621% that are going to two different outputs. So that's not a function. Is this a function? The answer is no. We have an input 5 going to two different outputs, a 1 and a 2. Is this relation a function? The answer is yes. Every X has one and only one Y. It is okay for different X's, different inputs, to go to the same output. Lesson objective. The rule of 4 for functions. We can describe some or all of the input-output pairs of a function by means of number 1, an equation, number 2, a graph, number 3, a table, or number 4, we can do it in words. These 4 ways to describe an input-output pairs of a function are together known as the rule of 4 for functions. Linear function. Definition. A linear function is a relation whose equation can be written in the form y equals mx plus b, where m and b are constant numbers. So this is the easiest type of function. And if we think about the rule of 4, so here we have the function, and if you recall from previous videos, we know that the graph of a linear function is a straight line. We have looked at tables of values, and we have looked at problems involving and words for linear equations have been some word problems that we've done in previous videos. For a linear function. We can express it as an equation, we can view its graph numerically, we can look at a table of values, and also in words. Lesson objective. To describe characteristics of functions, we will have to be able to express range of values using what's called inequalities or what's called interval notation. So here's an example of interval notation. Here we have what looks like an ordered pair AB, but it's not. This is an example of what's called an open interval and interval notation. So if we look at the graph, here we have a number line, here we have the value of A, and here we have the value of B, and we are wanting to express all values in between A and B. But it does not equal A and it does not equal B. So if we express this as an inequality, we would say X is a value in between A and B, but it doesn't equal A, it doesn't equal B. Now if we express this in interval notation, we would use a parenthesis that would correspond to an open circle. Then we put the smallest value, A, we put a comma, then we put the largest value, B, and since B is an open circle, we close it with the parenthesis. A closed interval, if we look at the graph, we're looking between two values, A and B, and we want all numbers in between, but this time it can't equal A and it can't equal B. So in this case, on the number line, this would be a solid circle and a solid circle. In inequality notation, we would include an equal sign for both parts, and then set notation. When it can equal a value, we use the closed bracket. Now, an indefinite interval involves infinity, and in this case, we have a number line here beginning at A, but it can't equal A, and then all values beyond A to positive infinity. Now the way we'd write this as an inequality is we would say any number X greater than A. It's not equal to because it can't equal A. If we write this in interval notation, again we start with the smallest value, A. It doesn't equal A, so we use a parenthesis, comma, and since there's not a maximum value, this is going on for infinity, we put the infinity symbol, and then we always, with the infinity symbol, use a parenthesis because we can never equal infinity, so we never use a bracket involving infinity. If we look at it from the other end, now we're talking about all values from negative infinity up to some value B. This time it can equal B, so that would be a solid circle here. And if we did inequalities, we would say these range of numbers are less than or equal to B. In interval notation, we start with the smallest again. Negative infinity, we use an open parenthesis because we can never reach or equal negative infinity. Then a comma. Then we put our largest value, in this case is B, and we use brackets because it can equal B. Here's a summary. If we think about two numbers where A is less than B, interval notation, parenthesis A comma B parenthesis is all values in between A and B, but not including A or B. X is in between A and B, so we say A is less than X, which is less than B. Interval notation, if we use brackets, the only thing that changes is it can equal A and it can equal B, and on our graph, instead of open circles on the endpoints, we would have solid circles. And of course this can be mixed up as far as brackets and parentheses, which would mean in this case it's in between A and B. It can equal A, but it can't equal B. Or parentheses A comma B bracket means it can't equal A, but it can equal B. If we have a graph that extends to infinity, like in this case, starting with A, all values greater than A, we would start with the smallest value. It can't equal A in this case, so we use parentheses, A, comma, and then we put the largest. In this case, this is going to positive infinity. If we look at the next example, the only difference is now we have a bracket instead of a parenthesis. If we look at the last two examples here, we are starting from negative infinity up to some value. So again, we start with the minimum, in this case negative infinity, comma, to the largest value, which is B. If it can equal B, it's a bracket. The last case, we have all real numbers and integral notation. That's from negative infinity to positive infinity. So that's all the numbers on the number line. Let's do an example. So for these three, we want to write this group of numbers using inequalities and using interval notation. So for the first one, we are wanting numbers in between -1 to 4. So for using inequalities, we start with our smallest value, -1. Our largest value is 4, and we want values in between these two numbers. That's our x. Now it can equal 4, so we can put an equal sign here, but it does not equal -1, so we do not put an equal to sign here. If we were to write this in interval notation, we start with the smallest, -1. It's a parenthesis because it can't equal -1, comma, we put the largest, which is 4, and since it can equal 4, we put a bracket. Now number 2, this time we want numbers in between 2.5 to 4. It can equal 2.5, it can equal 4. So we say 2.5, 4. All numbers in between, so x is in between. And then we put equal to signs for both inequality symbols. Interval notation, we put bracket, 2.5, comma, 4, bracket. So that's for number 2. And number 3, we have the numbers -4 going to positive infinity. This is all numbers greater than -4. So we say x is greater than -4. We don't put an equal to sign because that's an open circle. If we write it in interval notation, we put the smallest, which is -4. Put a parenthesis because it doesn't equal -4, comma, the largest, which is in positive infinity. Parenthesis because we can never equal positive infinity. Thanks for watching.